Hello, Reactathon. My name is Tyler. I'm a software engineer at Docker based right here in San Francisco. At Docker, I work on UI applications in our enterprise stack. We use many of my favorite technologies to build the UI at Docker. We use React, Redux, Emotion, and most recently, GraphQL. So recently, actually, that we haven't shipped a release with GraphQL yet. I was hoping we'd have wrapped up our release before I presented, but you all know how releases go. In just a few weeks, we'll be shipping Docker Enterprise Edition 2.0, which will be using GraphQL under the hood for the very first time. Just a little context on my work at Docker. I work on one of our enterprise offerings that provides Docker image management, kind of like Docker Hub on-prem. This product has been written in React and Redux since its inception and has been in production for several years. It is enterprise in that it is distributed to our customers and run on their own infrastructure by their own ops team. This presents a different set of problems than the software as a service products that I've worked on previously. We have to be careful with the changes that we make as they have immediate and historical effects. Missteps are costly, and changes can be slow. Adding GraphQL to a product like this took a different approach. We currently have a public REST API that has become limiting. Our data is complex, and our UI app had to compensate with an even more complex data layer to handle it. I knew that taking a different approach centered around GraphQL could drastically simplify our UI application. Getting the support from the team on adding a GraphQL server, though, is difficult. Understandably so. Adding a new server to our stack comes with some significant operations questions. Doubly so is we'd likely be using Node.js, something new to the team as well. How could we move the needle on GraphQL today? What if adding GraphQL didn't require a GraphQL server? Whoa. Turns out it doesn't. Adding a GraphQL to an existing React application, even when using a REST API, is actually really simple. We can use the same set of technologies we used to build a Node GraphQL server. By eliminating the need for server infrastructure, we can begin proving the value of GraphQL today with an architecture that allows for a server-side deployment in the future. So what does this implementation look like? How do we actually run GraphQL on the end user's device? In a traditional GraphQL setup, we serialize requests made by components and then send them over the wire. On the server, we hook an executable GraphQL schema up to a single HTTP endpoint, conventionally /GraphQL. The request is parsed and executed with the response serialized and passed back over the wire. Using the Apollo server package, a minimal implementation of a GraphQL server looks something like this. In a production setup, the HTTP server would be more advanced with auth, logging, etc., but the GraphQL schema would remain largely unchanged. When correctly designed, I believe the schema should be agnostic about the environment it gets executed in. For our client-side approach, we simply take the GraphQL interface and include it in our UI bundle, right in between the GraphQL client and the HTTP client. Instead of serializing the request, we pass them as JavaScript values directly to the schema. The schema resolvers call the HTTP client, which makes network requests against our REST API. Code-wise, it's incredibly simple to do. In a traditional GraphQL app, you would configure the Apollo client package to work with a remote HTTP server like this. To accommodate our client-side approach, we make a small change. Instead of using the HTTP link, we use the schema link, like the one also provided by the Apollo team, and pass in our schema directly. This single configuration change is all that is required. Our components keep defining their data dependencies the exact same way that we would if we had a remote GraphQL server. Our schema does not require any changes. As long as we're using a universal HTTP client to make requests in our resolvers, the schema can be run in both browser and server-side environments. Implementation is simple enough. Other than the overhead of adding GraphQL package to our bundle, the only serious cost of adding GraphQL to our application is the refactoring work required to use it. This is a non-trivial cost. If you've never worked with GraphQL, you might think that you just swap it out in your network layer. Instead of making REST requests, you make GraphQL requests. It's much more pervasive than that, in my experience, requiring a large change in how we build and structure our applications. How do we justify such a large refactor to our application? GraphQL brings some key improvements to our architecture, the largest being improvements to our data layer. When I say data layer, I'm referring to the state management, effect handling, and network layers in our app. We're all here today to learn about and discuss React, ostensibly a Vue library. The thing is that, in my experience, the Vue layer of our applications are actually really simple. If all we had to do as UI developers was write functional, stateless components, we probably wouldn't have jobs anymore. The real difficult parts of building our UI happen in this data layer. Flux implementations like Redux give us the tools necessary to solve these problems, but they don't actually solve them for us. In my opinion, they are bare bones tools. The path to building a complete data layer from scratch on top of a Flux implementation is lined with questions, blog posts, and a lot of misdirection. The first few times I built a Redux store, I did it wrong. Unless you already have the experience and foresight to consider things like caching, batching, optimistic updates, and real-time data from the beginning, there's a good chance you'll need to rewrite your data layer at some point during the development cycle. There is a better way, though. Due to the normalization of GraphQL data, our GraphQL clients can make some large assumptions and remove the need to build out much of this data layer infrastructure by hand. We found that using GraphQL client instead of a hand-rolled Flux architecture simplifies our UI application significantly. Personally, I'd say by an order of magnitude. No more orchestrating requests. No more mapping remote data to our client-side state. No more writing imperative code to resolve our data dependencies. The next largest improvement we found were better component APIs. As a UI developer, I spend a lot of time considering component APIs and how other developers interact with them. Do we pass in scalars as props, or objects, or some mix? How do we namespace our props? We use prop type declarations to improve the development experience and avoid type errors, but they don't tell us that much. Consider this example. Can we pass in any string as a first or last name, or just a string from a specific data source? Once our components speak GraphQL, a lot of these questions start answering themselves. Instead of passing random values between components, we pass GraphQL types. Nearly any component in our user domain accepts a user GraphQL type as its main prop. It's simple. In addition to simplifying questions around component APIs, the use of GraphQL fragments also tells us a lot about where our data comes from. This is a very powerful tool, as we can define data dependencies statically without having to connect our components directly. Components further up the tree can then compose these data dependencies via fragment composition. In Redux, it's common to follow a container presentational component pattern as a basic separation of concerns. This pattern works out great until your deeply nested presentational components change their data dependencies. All of a sudden, you're connecting components all over the element tree. With GraphQL, we can blur the line between container and presentational with static data dependencies described as GraphQL fragments. Finally, near the top of the element tree, we actually connect to our data sources. Our page-level components can accumulate the data dependencies of all their descendants and resolve that data all at once. Previously, we had cascading data dependencies as components all over the element tree independently resolve their data. This resulted in a lot of complex loading states, possible race conditions, general overfetching. With GraphQL, these issues have all but disappeared. This GraphQL flavor of container presentational pattern has worked out very well for us. Many times, a developer can build out an entire feature without ever writing a container or interacting with the data layer directly. They simply write functional components with static data dependencies described as GraphQL fragments. The last major improvement comes from the data modeling capabilities of GraphQL. As React developers, we can sometimes neglect the modeling step in building a data layer. We just deal with the view all day, right? We jump straight into implementation. We install Redux, we start writing actions, reducers, and selectors. Some of the biggest mistakes I've made as a UI developer started just like that. GraphQL formalizes this data modeling step for us. As you build your schema, you'll be pushed to model your data in a graph, which alone is its own benefit. Graphs provide a very natural way to describe and request data. In addition, you will need to statically type all the possible values that pass through your GraphQL interface, which then can serve as the source for code-gen, JavaScript type annotations for the rest of your application. These days, the first thing I write down are my GraphQL types. Everything falls into place very easily after that. Our setup at Docker has worked out great so far. Other than the increased bundle size, we haven't really seen any negatives. However, we know there's room for improvement. We'd really like to move our GraphQL interface to the server and reconsider the structure of our core services. Unfortunately, we can't directly replace our existing REST API with the GraphQL one. For one, our customers rely on it, the downsides of having a public API. In addition, it's not currently built as a separate layer. The next step would need to be another hybrid approach. Moving GraphQL to our server layer is not so complicated. The majority of the work required is exterior to GraphQL, mostly just getting a production-grade node server configured and approved. I believe the code base for our GraphQL interface should remain nearly untouched during this transition period. After moving our GraphQL interface to the server, our next step would be to remove its dependency on the REST API. This is a much larger task as it affects our stack at a much higher level. In the most optimal scenario, I see our services exposing themselves via something like gRPC, with both a REST and GraphQL interface directly in front of it. By abstracting the REST layer away from our core services, we can unshackle ourselves from this public REST API, which would be a huge step forward for us. The service layer would be much simpler, no more swagger. The REST interface could share much of the same code with the GraphQL interface, Node HTTP server, JS models, testing tools, et cetera. Right now, our UI team doesn't own any of the server infrastructure in our applications. One of the things I've come to realize after working with GraphQL is that UI developers know good APIs. We're the primary consumer of them. GraphQL gives us a chance to build better APIs, and I believe it's within our domain as UI developers to build and maintain them. Going forward, I would love to see our UI team completely own our API interface layer in our products. While our current approach is novel, I can envision a future where running GraphQL on the client is not so uncommon. I'm sure many of you are already familiar with the concept of dapps, or decentralized applications. In the dapp paradigm, we rely on decentralized blockchain networks instead of centralized private infrastructure to host the most remote portions of our application. The end user interacts with an application running on their own device to communicate directly with the blockchain. This interaction is made possible via things like the Web3 JavaScript APIs for the Ethereum blockchain and browser extensions like MetaMask. This architecture begs a question, though. With no server in between the end user's device and the blockchain, where does GraphQL fit in? It fits in on the client. Using GraphQL in a local schema, we can write resolvers that call the Web3 APIs exposed on the end user's device and communicate with the blockchain. Running GraphQL on the client in the world of dapps is not that crazy. That's not to say we wouldn't have some remote GraphQL infrastructure as well. The ad hoc server infrastructure in our application could easily be GraphQL-based. Using schema stitching methods, we can combine remote GraphQL services together with our local schema to produce a universal interface for our dapp. Blockchain tech presents some really interesting and exciting opportunities for UI developers. If the dapp revolution comes to be, our UI applications will take on new life and a much larger role in our stack. React and GraphQL are a fantastic pairing that can help us build the applications of today and tomorrow. If you have any questions about our approach or just want to talk GraphQL, you can reach me in these places or in the hallway during the conference. Other than the hallway, React to Flux is your best bet. One last note, we're hiring senior front-end engineers at Docker, so if you like React and GraphQL and you're looking for a job, come find me. Thanks.
Cool, thanks.